Bismillahirrahmanirrahim. Let's go over the lead compensator design. And in the previous lecture, we went over one example of a lead compensator design. And in that example, the uh, loop transfer function was given like k over s plus alpha, and we needed to satisfy the design criteria, which was steady state error, uh, the requirement of steady state error, and the phase margin. Phase margin is the requirement, phase margin is the criteria which is defined on the loop transfer function directly, and the other criteria was the steady state error. So steady state error, it is directly related to the loop transfer function by calculating the error constant. So we had both the criteria of uh, both the requirements which were directly related to the loop transfer function. And we calculated the value of k in the previous example, which was example 10.2. We calculated the value of k based upon the requirement of the error constant, and after satisfying the error constant, we uh, calculated the phase margin, and we compared that phase margin to the required phase margin, and the deficient phase was added using a lead compensator. So in the nutshell, we had both of the criteria which were directly related to the phase margin, and calculation was much easier and simple. Now let's go over the example 10.1, uh, which I skipped because it was a bit involved. 10.1, and why it is involved, a bit involved, because we have certain criteria, certain design criteria which is not directly map related to the loop transfer function, and that criteria is the settling time of the closed loop system. Settling time of the closed loop system. If I am given the settling time of the closed loop system, then uh, it's a bit tricky to satisfy that requirement. Now, let's go over the example, and before that, I'm gonna just in a minute revise the steps. The steps of the compensator design will stay the same. And what are the steps? Steps are lead compensator design steps. Compensator lead compensator design procedure, and we'll use the same procedure but in a different but satisfying some other requirements compared to the example 2. So let's revise the lead compensator design procedure. First, I'm just going to write the major steps. First, uh, plot open loop, or you can say loop transfer function body, and calculate existing phase margin. Number 2, compare it it with required phase margin, which We calculated from some requirements, just like it can be a requirement of the damping ratio or whatever. So compare the existing phase margin with the required phase margin and calculate additional phase required. Number three, using additional phase requirement, calculate alpha using sine phi m is equal to alpha minus 1 over alpha plus 1. And this is additional phase, not the total phase margin. This is additional phase margin on top of existing phase margin. Once you calculate alpha, then uh, calculate 10 log alpha, find frequency on existing loop transfer function body, where magnitude is minus 10 log alpha, and that frequency is omega gain crossover, new gain crossover frequency.